Hello friends, here the computer network class. In previous class we have learned media access control protocols. In media access protocol there are three types of media access control: the partitioning, random access and taking turn. Partitioning is a part of physical layer and the taking term is not in our syllabus. So we will learn a random access protocol. In random access protocol there are two types. So the random access protocols random access MAC protocols are divided into two categories: Aloha and CSMA. Aloha has two parts: pure Aloha and slotted Aloha. Aloha is used mostly for satellite communication or wireless. CSMA carrier access multiple access control protocol, CSMA CD and CSMA CE, which is used for wide medium. So here we learn pure Aloha. Random access protocols: Aloha, pure Aloha. So here pure Aloha. Pure Aloha band to use pure Aloha. So when the node has a packet to transmit immediately. If there is a node want to send the packets and have it means node have the packet to transmit. If the node have the packet to transmit, then it transmit it immediately in the channel, whether the channel is free or not. Okay. Here the protocol says that if there is a collision in the channel, then it can wear the channel, and to recover the collision it can retransmit the packets again. Means that if transmitter send the packet to the channel, and if the collisions happen, then it recover the collision by retransmitting the packets again. Okay. We use randomization in choosing when to transmit the nodes. When the collision happens, node retransmit the frames again, but that time or the frequency need to transmit the frame again is randomization. Means in random time, if the collision happens in some random manners, it transmits the frames to the channel again. Here in pure Aloha, all frame sizes are equal. Okay, all frame sizes are equal in pure Aloha. Receivers and acknowledgement to source means for every correctly without closure received framed. Means if the frame received by the receiver correctly, then it sends the acknowledgement to the transmitter. Again, if the receiver received the frame correctly, successfully, then receiver send acknowledgement to the transmitter end. Okay. Here after transmitting the frames, source is transmitter wait for the acknowledgement up to timeout. What is timeout? Timeout is a round trip time. Or what is round trip time? Round trip time is 2 TP. TP for go and TP for come back. There is 2 TP. Here there is a channel. In channel there is a 4 host. Have 4 hosts send their packets in the channel. Here the frame A packets, frame here host B frames, host C frames, and host D frames. So here, as we say, here the frame A and frame C packets overlap, means collide. Here the frame A and frame C, host A and host C frames collide. But here the host B and only host B packets are not collide because there is no any frames adjacent to the frame B. B frame के adjacent में कोई भी दूसरा frame नहीं है. This way, because of this, it will not collide. So we have to need to find vulnerable time. What is vulnerable time? The time at which or a time duration in which no transmission should be done to avoid collision. The time duration at which no transmission should be done to avoid the collision. So here the frame having a t of x transmission time, t of x, and we will take t minus tx. Here t minus tx and here t plus x. So there is a 2tx. This is a 2tx time. So here in case of pure Aloha, vulnerable time is 2 time of transmission delay. 2 into transmission delay. Okay. The vulnerable time, you must remember the formula. The vulnerable time for pure Aloha is 2tx. 2 into transmission time. Okay. Must remember. Okay. Now here G. What is G? G is the mean number of transmission per frames. मतलब एक फ्रेम टाइम पे number of transmission done by the other host. Transmission done by the other source given number of time or transmission time. So again, mean number transmission per frame means average number of frames transmitted in one frame transmission time. Here the transmission time is tx. So the number of frames transmitted by the other host in t of x time is called G, mean number transmission. Throughputs क्या होता है? What is throughputs? The average number of frames transmitted successfully in one frame transmission. Here the number of frame, here G क्या है? What is G? G is the number of frames transmitted per t of x time. Here the number of frames successfully transmitted per frame time is the number of frame successfully received by the receiver at this transmission time without any collision. Is that here the total number of frames transmitted, and here total number of successfully frame received. Total number of frames successfully received at between the transmission time. Okay. Now the probability that the frame does not involve collision. P is a probability that frame does not involve collision. Probability of the frame that the frame does not involve collision. The probability of frames collision does not involve collision means that here the probability that the frame does not involve in collision. The probability of successfully transmission of frame. Probability of successful transmission. Okay. Here the most important formula according to Poisson distribution theorem. According to Poisson distribution theorem, P is equal to e की power 2g. Then after putting value of P in previous formula, S into here the S is equal to G into P. Okay. We get S is equal to G into e to the power G. So when the throughput is maximum, so yes, is when the x is maximum. For to find the x is maximum, we will differentiate it and get the value of g at which the s is maximum. So we get g 0.5 at g 0.25. At the value of g 0.05, the throughput is maximum. And what is the maximum throughput? At 0.5. After putting the value of g 0.5, we get s 1 upon 2e. Must remember 1 upon 2 is the 1 upon 2, which is a constant value, means maximum throughput. Can we achieve maximum throughput? We can achieve in pure Aloho is 1 upon 2e, which is a constant. The value of this is 0.183, say 80%. So here the efficiency, we can say efficiency of the pure Aloho is 18.39%, which is a constant. And at what value? At value of g, at the value of g 0.5, 0.5 is 1 by 2. At the value of g 1.2, 1 by 2, the throughput is maximum, and the maximum throughput value is 1 upon 2e. Must remember 1 upon 2e, which is 18%. So the efficiency of the pure Aloho is 18.3%. Okay. So thank you, friends. You can download the PDF. I already uploaded the PDFs in Telegram channels. This channel is link in description, where you can access all PDFs of previous lecture and present lectures. Thank you.